So again, our Common Core has to do with logarithms, okay? And it is functions, I, F for interpreting functions, E, and it talks about graphing, exponential, and we're going to skip exponential because I'm not really going to do the exponential, and logarithmic functions, okay? So what is a logarithm? It's an exponent. It really is. In fact, if we look right up here, I have circle log of some base of a. This is a logarithm. What does it equal? E. The E stands for the exponent. Okay, this is exponential form and this is log form. So this is my log form and this is my exponential form. Alright? So we can rewrite it from log to exponential. We can go b to the e equals a, or the base to the exponent equals a, alright? So what we're going to do is practice that. And in order to practice it, on the very first one, it doesn't have a base. But if it doesn't have a base, it's always 10. It's always 10. So I'm just going to write the 10 in there. And we don't write the 10 if it's common log. The common log is the exact same log that's in our calculator, okay? So if it doesn't have a base, write it. Now watch. Everybody watch. We're going to do this. Everybody, 10 to the 2 power equals 100. I'll say it again. I'm going to go 10 to the 2 power equals 100. So I'm going to go 10 to the 2 power equals 100. So I just changed it from log form to exponential form. I went 10, the base, to the exponent equals what's inside. That's all I did. B, we're going to go 3 to the 4th power equals 81. That's all I'm going to do. I'm changing it from log form to next one. I'm going to go 3 to the 4th power equals 81. How about the third one? What do you guys think? 5 to the negative 1 power equals 0.2. And that is true. That's what it is. It turns out to be 1/5. So you just changed from log form to exponential form. That's all we did. It's just doing the inverse of it, okay? Now example 2 is just going to be doing the opposite. This is the base. The 10 is the base. The 8 is the base. So I go log of my base, of base 10, of my answer, which is 100,000, equals 5. So here's my base. So I go log of the base, log base 10 of 100,000 equals 5. That's all I do. Okay, how about B? How would you write B? Log base 8, good, of 2 equals, that's it. That's all. That's all you do. Now you can't do base 8. These calculators will only do base 10 and base E. Some of the special calculators, some of the newer ones can do any base, but my calculators will only do base 10 and base E, okay? All right, now evaluate the following. So first of all, number 1, on the first A, you can use your calculator. You can, but I'm going to do it without. You can just go straight to, boom, you just go straight to it and go log 1,000. But before I hit enter, I know the answer is 3. I know the answer is 3. Because 10, because it's got to be base 10, right? 10 to what power equals 1,000? 3. It really is. So if I set this equal to x, I can go, okay, 10 to what power equals 1,000? I know it's 3, right? And sure enough, boom, enter, what's it equal? 3, okay? I knew that. But now if it's not base 10, we're going to have to do some thinking. We're going to have to use our brain. So B, let's go. I like to set it equal to x. 2 to the x, 2 to the x power equals 32. Well, what's x?
8.
Nope.
6.
Nope.
4.
Nope. I just heard it say it.
5.
5. Now, did you guess on 5 or did you went? Hopefully, why went? Wait a minute. 2 times 2 is 4 times 2 is 8 times 2 is 16 times 2 is 32. How many 2's did I say? So x equals 2 because 2 to the 5th power. 5. Yeah, thanks, Marie. It's got to be 5. 2 times 2 is 4, times 2 is 8, times 2 is 16, times 2 is 32. Okay, how about C? Let's rewrite it. Let's go 16 to the x power. 16 to the x power equals 4, okay? How can I make 16 into a 4?
It would be a negative number.
Close. It would be a square root. Yes. So the square root of 4, oh, I'm sorry, my bad. The square root of 16 is 4, right? But what's that as an exponent? Yes, 1/2. It's x equals 1/2 because a 1/2 makes a square root. Square root's exactly right. So the power is a 1/2 power. Okay, D. Let's go the other way. So to go the other way, I just set it again. And you set it equal to something, so set it equal to x. There's my x. We'll go 5 to the x equals 1, right? 5 to the x equals 1. Okay. What's x have to be?
0.
Yes. Anything that 0 powers 1 has to be 0. Totally correct. Okay, good. Okay, set it equal to something, okay? So let's go. Now it's in exponential, so let's change to log form. So we'll go log. What's my base? It's this base 5, right? Log of base 5 of the answer, which is x, equals what's the exponent, which is log base 5 of 12. I'm out of room. So what's x have to be? What's x have to be? 12. It's got to be 12. Hey, I think in our reading, though, I wouldn't have had to have done all that work if I just looked at my reading. Wait a minute. Wait a minute. If I take a look at this problem right here, go to my reading, and if I go to that property right here, it would have worked. See this property right here? I could have gone straight to 12, right? All right, that's a nice little rule, okay? F. ln. ln has a base. What's the base of ln? I'm running out of room, but I'll squeeze it in here. Yeah, so it's log of base e of e to the 4, right? I think we got a rule like that here too somewhere. Somewhere don't we have a rule like that? I think we do. I think it's right there. Log of a to the e, log of e to e. What do you think the answer is? So take a look here. What's the answer? I think it's 4. In fact, I think I could probably do the original on my calculator. I bet I could. Because it's all just a bunch of numbers, right? And I can use my ln. Check this out. I bet I could do it clear. I bet I can do this one on my calculator. I bet I can go ln e to the 4 power. And I think the answer is 4. What do you know? What do you know? Okay, turn the page. Okay, graph. 2 plus log to the negative x. So before we do this, let's go ahead and go back to our reading. What are these? They look like this pink one right here. So let's take a look at that graph and just draw that one up above. So let's take a look at my log graphs, okay? Let me do that real quick, okay? All right, let me put in some things. So I do know it goes through at 1, and my log graph looks like this. So my log graph looks like, okay? That's my parent function, okay? That's just my plain old y equals log of x. So how am I going to graph this one? Anybody have any suggestions?
Plug it into the calculator.
That will work. I can do it. Up 2, yes. So if I go up 2, this bend point is going to be here. Up 2, totally right, Will. And then what else? It goes the other way. It does. It goes that direction. So it's going to look like this. And that means that this asymptote is going to be sitting right about here. It's going to look like this.
Is that like positive 2?
And then I should be able to check it on the calculator anyway, right? Because, I mean, you know, if it goes to calculus, figure that out, right? So now that got put on. So y equals, let's see, 2 plus log of negative x. Let's see what it looks like. Oh, what do you know? Now it just stops there. How come it just stops there?
You've got an asymptote?
It becomes so steep you can't see it, right? It does. It makes an asymptote, but it becomes so steep the calculator won't graph it. But it does go down that way. It really does. It really does go down. But the problem with calculus is the calculus won't graph things that are not functions, and it thinks it's not a function by how steep it is, okay? But it does go down, okay? All right, solve. How am I going to solve for x? Any ideas? Well, I got a log of x. Does it have a base?
No, it means it's 10.
Yeah. So if I put a 10 here, now what would you do to solve it?
Figure out what it needs to mean.
Yeah. Yeah. I think, me personally, I would change from log form to exponential form. I'd go from log form to exponential form. Well, how could you rewrite this? How can you go from there to there?
10 to the x.
Yes, 10, not 10 to the x, but 10 to the 2.1 equals x. I think my calculator will do that. What do you guys think? I can go 10 to the 2.1, and I get an answer about 125.9. Approximately equals x, okay? B. How do I do B?
It's just like ln, no. E to the
E has a hidden base E. Nice job, Will. Guys, remember ln has a base E. And then let's do the same thing you did here. What do you think? Same thing you did here. What are you going to do? E to the second power equals x. And again, our calculator can do that. I know that. I know my calculator can do that. If I go e to the 2 gives me an answer about 7.4. Approximately equal to x 7.4. Okay. How about 2? How about C? How about the last one? C. 2 to the negative 3 equals x. Totally right. 2 to the negative 3 equals x. And that is 1 over 2 cubed, which is 1/8. Okay. Now, just a suggestion. You need practice on this, don't you? You need practice. You need practice. You really do. I would suggest that you do the homework. Okay? I would suggest instead of just goofing off,